Hi everyone, in this video I'm going to walk you through some of the information for questions 2 and 3 from Project 2, the Cantor set. So in question 2, you're given some definitions about interval notation. Interval notation is something that you may have seen before in a previous algebra class, or maybe you have not seen it before. Interval notation is just a way that we can show a chunk or a slice of the number line by listing the smallest element and then the largest element separated by a comma and enclosed with either parentheses or brackets or a combination of one of each. So imagine you have a number line and you just want to slice it from one number to another. And you may or may not want to include the endpoints of where you're slicing that number line. An interval notation can help us to write a shorthand description of that slice and also indicate whether or not we want to include the endpoints or not including. You might have seen something similar to this if you had learned about inequalities. We have inequalities that can be equal to or cannot be equal to. So you might have seen an open or closed circle when you're shading on a number line. Interval notation is related to that. It's just another way that we can write a section of values on the real number line. So we'll be using fully closed and fully open intervals in this project. A closed interval means that the endpoints are included. In the example, you see the closed interval 3, 5. So imagine you have a number line and you're just focusing on the section between the integers 3 and 5, including all the numbers between 3 and 5, not just the integer numbers, all of the real numbers. So 3.7, 3.99991, 4.2, 4.999, all the way up through and including 5. The 3 is included as well, and that's why we use the square brackets or just brackets around both the 3 and the 5. So that would be a slice of the number line including 3 and 5 and every number in between. We'll also use open intervals in this project. Open intervals are intervals of the number line where both endpoints are not included. So in the example, you have the open interval from -1 to 2. So that means all of the values between -1 and 2 are included, every real number that lives between -1 and 2, not just the integers, but -1 and 2 are not themselves included in that interval. So we use parentheses to show that they are not included. So you're going to use that notation in the next question. Eventually, you'll also be talking about an intersection of a sequence of sets. So let's talk about that notation as well. So we talked about intersection of two sets in past lectures. An intersection in general just means that you're focusing on where two or more sets overlap each other. So most of the examples we've seen have had 2 or 3 sets at most, but we can have more than that. So we could even potentially have an interval of, or an intersection of infinite sets. In this example that you see on your page, you have notation for an intersection of 5 sets. Each set is designated with a capital C and a subscript. So the general form is C sub k, but k can be any value between 1 and 5. Those are counting numbers from 1 to 5. So C1, C2, C3, C4, and C5 are 5 different sets. And between each of those sets, you see the intersection symbol, which means we're looking at these 5 sets and where they all overlap. So if you could imagine a Venn diagram with 5 circles, and at some point, all 5 of those circles will overlap in some region. That is what we're referring to using this notation. Okay, so the first thing that we should talk about is how to construct the Cantor set. So in this picture, you have an interval of the number line. So this green bar, just imagine, is just a slice of that number line from 0 to 1. The interval is given here. So this set C1 is defined as the interval of numbers from 0 to 1, including 0 and 1. Note that there are brackets around the endpoints. Remember, a set is just a collection of objects. In this case, we're looking at a collection of real numbers. There's no way that we could list all of the real numbers between 0 and 1. It is impossible. So we have no other way to represent this set other than using this interval notation. The first thing you're asked is to give the length of C1. So we're measuring this on a number line. So just how many units is it from 0 to 1? And again, you're not measuring that with inches or centimeters, you're just measuring it in units. So there is one whole unit between 0 and 1. So we would say that the length of C1 is 1. And so that's your starting set. In order for us to get the next set, C2, we are going to slice C1 into 3 equal pieces and then remove the middle third, or the middle piece of those 3. So imagine I slice here and I slice about here and then I erase what's between. I get the picture that you see below. So I've taken that middle third out and I have indicators of where I've made those slices. So I've sliced at 1/3 and at 2/3 because I wanted to create 3 equal pieces. So each of them measures 1/3. Now we are keeping these endpoints of 1/3 and of 2/3. So the next thing you're going to have to do is express C2 as the union of 2 closed intervals. So this is one interval from 0 to 1/3. So you can write that in that closed interval notation, similar to what you see here. But the difference is now this first interval will go from 0 to 1/3. So instead of this 1, you'll have 1/3. But because we are going to include the endpoints, you will use brackets around that first interval. But C2 does not just have this one piece, it has another piece as well. So we're going to write C2 as the union of 2 closed intervals. So the first closed interval will be bracket. I'll try to type this in here. So bracket 0, comma 1/3. There's my first interval. Then you're going to use the union symbol just for ease. I'm just going to use a capital U right now, but when you're entering in Blackboard, you have the union symbols in the math editor button. My second interval, or the second part of that piece, goes from 2/3 to 1. So another closed interval from 2/3 to 1. Just move this back over. So this would be a way that we could represent C2 by listing both of the intervals. Notice we're using the union operation. There's no overlap of these two sections of the number line, so it wouldn't make sense for us to even think about intersection right now. The next thing you're asked to do is to represent the length of C2. That's the total length of what you see here in green. Remember, we did shorten the original length, so we have 2 pieces here, and each of them is length 1/3. So if this is 1/3 and this is another 1/3, the total length that we have left would be 2/3. So next you're asked to write an interval for the complement of C2. So remember, this apostrophe symbol stands for complement. So the complement is the interval that we cut out. So we cut out everything from 1/3 to 2/3, but we didn't cut out 1/3 and we didn't cut out 2/3. So we're going to use an open interval, so parentheses. We removed from 1/3 to 2/3. And then again, using parentheses around the 2/3 because we didn't cut out the 2/3, we kept it as part of the C2, part of this green shaded region. So then you'll continue this process for on C2 to get C3. So try to match these up so the lengths are the same. So imagine taking C2 on each of these pieces. You're going to cut out the middle third, cut out the middle third, and then you'll have the image that you see here. I want you to label the endpoints where we made the slices and use the endpoints that were already there from the prior picture. So you already have these endpoints. Those endpoints will stay. Then you'll have new endpoints that you need to identify. Once you identify those in fraction form, you're going to do the same thing we did for the last part. Now C3 has 4 pieces, so you will write a union of 4 closed intervals. Again, label your endpoints with fractions. Then you're going to find the total length of these 4 pieces. So imagine we slid these pieces together and then measured it against that first interval from 0 to 1. What is the fraction that represents the length of C3? Enter that here. And then you'll write an interval for C3 prime, the complement of C3. The complement of C3 is the set of open intervals that have been removed. So including the piece that was removed originally in the first stage, you're going to include that, and including the 2 new pieces that have been removed. So you'll enter that here and also in Blackboard.